Hello and welcome to the Media Technology Lab here at the University of Sussex. And to start off, Dr. Andy Philippides.
Hello. So, welcome everyone to the computing, the specific part of this thing. So, I think you've had quite a lot of talk already, and I think you are all very well aware that computing is more than just spreadsheets. And as everyone's been saying, computers are everywhere, but it is appearing on our phones, on our iPads, and in our white goods. I think what people haven't emphasised so much is why it's interesting for us, is because it means that the things that we have computers in are changing very, very rapidly. And so we've got interactions between new devices and between devices that are changing. So if we need to make programs that enable communication between these things, we've got to sort of anticipate what are going to be the new devices. Also, it means the cutting edge is within reach. The things that you will be learning will be the cutting edge of tomorrow. So it's a very exciting time for us. It's quite a challenging time, but very exciting. So what is informatics? Why aren't we called computer science? Well, informatics is the study of the storage, transformation, and communication of information, with information being pretty much everything. Words we write, images, sounds, measurements, changes made on the world. So we see computer science as a way of taking information from one place, playing with it, and doing something else with it, okay, in its most general form, whether it's through video that you capture on your phone that you might upload to Facebook and then someone, I don't know, later steals your identity or something fun like that. Anything like that, but it's taking information from one place to another and doing something with it in between. So this is a quote by Joe Hellerstein in 2008. So he said, we're now entering the industrial revolution of data, where data is going to be stamped out by machines, software logs, cameras, wireless sensor networks, and so on. And so what we need is we need computer scientists who can develop systems that process this data. It's all well and good having all this data out there. And there is data out there, as Diane was saying, Facebook are spying on you with your consent. Little known fact is that they could also, whatever other windows you've got up in your browser on different tabs, so Facebook will be monitoring those other tabs, okay? And they will be able to see. I think in the last 3-4 years, the adverts that you get, the free adverts that you get, are starting to get much more targeted. They used to be really random, and now they're actually pretty much on the money of stuff you might want to get, or often stuff you've just already bought from somewhere else. But they're very targeted to you. Good thing, bad thing, who knows really, but you know that's the thing, and it's all driven by data, and we need people who can process that, or you'll at least be paid if you can do that. Whether we need it or not is probably a more philosophical question. So why should you come here? Well, we are a world-class university. Our computing skills are widely sought by employers. I am currently advertising for a post, a starting salary up to 27, and it's 27,000, and I haven't had any applicants from Sussex. They've all, I think, got jobs, which is really annoying. So, you do get good skills, and you will get jobs at the end of it. More importantly, I think it's what we teach is what we do. So as David emphasised, the things that we teach is driven by either our research or our industrial links. This means it's both up to date, it should be very, very current, and we should also be enthusiastic about it. Quite frankly, nobody is excited about my research as I am, and very few of them are even half as excited as I am. But at least I'm going to be enthusiastic about what I teach. I'm going to believe in it, and I should, if I'm any good, know what's going on in the wider world around. So I think this is really important, and this is why we've got many degrees which reflect the things that we do. We've got very good facilities, and it's a nice place to be, quite frankly. So what do we do? So Diane spoke about this, so I won't cover it too much, but essentially it's interdisciplinary research and industrial consultancy is our kind of the things that we do. And interdisciplinary is very important. So computing is everywhere. My research is mainly biology that I do through computer science. It's got some applications to engineering, but mainly it's biology. I'm trying to understand brains, trying to understand what goes on in brains. And this here is a TV studio. It's a working TV studio. So computing really is crossing over into all disciplines, and this is why I highlight this. So we've got the Foundations group who are looking at new languages and technologies, and they will be teaching you courses about the constructs of languages and what you need, computing languages. We've got cognitive systems, people trying to understand cognition, understand the brain, and how things work. And we will be teaching you artificial intelligence, adaptive systems, interactive systems, how we interact with technology. We will teach you human-computer interaction. We will teach you video processing and things like that. Adaptive systems, my area. Anything from autonomous robots to consciousness. This is the things we work on, and these are the things we're going to teach you about. We've also got very good support for learning. So we lead the way in innovative student support, being a technology-led department. We've got the videos that we do some teaching in here, and we record the videos and put them online, so you can watch them later at your leisure. This allows us, for instance, to put a signer on for deaf students. It's also particularly good when one is demonstrating a new programming language or a new bit of kit, a new bit of software, because you really want to go back and look at it later. You don't want to take everything in. You want to be able to see these things again. We've had a lot of input into this website. So this is the S3 website. If you come here, we would advise you to look at this website before you come, because it's very good for things on how you bridge the gap between school or college and university. We've got nice resources and facilities. You're going to see the computing labs now, and I think you'll all be seeing them in a second. So this is our computing labs. They're open 24/7. These are our studious students working away with never a sound amongst them. And as I said, they're open 24 hours a day, 7 days a week, and only for us. We've got specialist lab facilities, the digital media lab that you're in. We've got various robots, and we've also got an Interact lab. Funding and housing. So we've got various funding schemes. There's the First Generation Scholar Scheme, which I think is on, if you get help if you're on a family income under about 45,000. There's also our own High Flyer Scholarship. There's Care Leavers Bursary. There's also a new one, which is the Sussex Graduate Scholarships, which is if you end up getting a 2-1 or a first, then I think you get £2,000 towards doing a master's here. Housing, if you want guaranteed housing, you've got to pick us as first choice and return your form by 1st of August. And then you get housing in your first year, guaranteed on campus. So maybe more interestingly, what can you expect? What's the main difference between what you've been doing and what you may be doing here? Well, rather than using software, you're going to be creating software. So rather than using a piece of software that makes it easy to make a particular web page, you're maybe going to create that bit of software that makes it easy for other people to make web pages. We're friendly, I think. We're approachable. And you're going to be hopefully surrounded by bright and motivated students. Well, you will be surrounded by bright and motivated students, which is always a good learning environment. You're going to be 2 12-week teaching terms. There's assessment after each term, which is a mix of coursework and exams. There are some exams. There are more exams in your first year, probably about 60% of your work exams. Then it goes down to about maybe 40%, 50% in the second year, and then very few exams in the third year. Typical week, you're going to have 4 courses, or 4 modules, I should say. 1 to 2 hours of lectures, 1 to 2 hours of seminars, lab classes or practicals. Normally about 15 hours of contact time per week, okay? And we would expect you to do at least the same on your own. Computing is a practical course, and you need to practice it. You need to be in the labs doing things. I mean, you can do it at home, but you need to be doing that same amount of time on your own. So these are the courses we can study. Computer science, digital media, computer science and AI, games and multimedia environments, computing for business and management, and then this foundation year which leads into any of these courses. What is on them? Well, programming. Everybody's got to learn to program. First language we teach is Java, but there are various other languages you'll come across. A bit of Flash, HTML, SQL, Prolog, MATLAB, C#, JavaScript, Python, Haskell, all sorts of things. Various different languages. So together with this, we teach foundations. And this is basically a course that we teach about the logic of programming and all the elements you need to make a programming language. So with this, allied to some practical programming experience, we think you can then turn your hand to learning anything. Okay? Most languages have similar elements. And so this teaches you about those elements. And then when in 3 years' time the next funky language comes along, you're ready for it and you can adopt it. Software engineering is a practice of programming, how you work in teams, how you work in industry. And so we assess this with a group-based, team-based project as you would get in industry. Computer systems, how all these things fit together, the operating system, how they work with databases, how they work with compilers, how all these different elements interact. Professional issues, how you're going to get a job afterwards, how you present yourself, how you present your work. Web computing, computing for the web, HTML, but also about how networks interact. What do we do if we don't want data to drop out when we're on wireless networks and we've got the phone that keeps connecting or not connecting? What protocols do we send to make sure the packets of information get across? Those different things. Management, mainly for the business and management course. In fact, almost entirely for that. But these themes are taught by some of them are taught by our lecturers, e-commerce, and things, and some of them are taught by the management school. Intelligent systems, artificial intelligence. How do we make computers think? Natural language processing. You've heard about this, but in one of the course samplers, so David Weir is going to talk to you about this. He'll show you some stuff they've been doing with analysing Twitter and social media to try and extract sentiment from text. It's not that easy, but it's quite easy to parse the text and get text nowadays. But how do we extract the sentiment from it? You know. So David will talk a bit more about that. Robotics and adaptive systems. So this is my area. So I've told a few of you I study insect-inspired navigation in robots. So here, these are some of my smaller robots that are running around. And acting autonomously, and they're acting on their own. So the idea here is I want to understand what it means for something to be autonomous, what elements do you need for something to be able to adapt. And so this is a course that I teach on acquired intelligence and adaptive behaviour, where we play with some of the Lego robots and look at what it means for these things to react and how we can be inspired by nature to get solutions that work in the real world. This is one of our bigger robots there. So that's that. We've got graphics and animation, which Paul is going to tell you about. Similarly, music and audio, he'll tell you a bit more about this. So we have all these themes, and how do they line up? So this is the computer science degree. You've got programming, foundation, software engineering, the computer systems and professional issues. So these are the kind of major course themes. And then the smaller ones, there's less of them, and sometimes it's a bit optional as to how much of one you can fit in and out. So you've got some graphics, you've got some AI, a bit of robotics maybe, that's kind of optional, and some web computing, and that's kind of optional. Computer science and artificial intelligence in contrast. So we've dropped out some of the foundations. You will still do some foundations, some computer systems, but less of them. But more of the AI and definitely more of the robotics and adaptive systems. Business and management. Now management has slipped in and become a bigger theme, and the AI and robotics has kind of dropped out with less of the foundations, okay? So this is kind of how it works around. So the idea is that you choose your speciality. The first year gives you the foundations, specialisms are introduced in the second and third years, and most of year 3 is specialised. And this is purposeful. The first year is generic, which gives you a taste of all the different strands and allows you to switch. You can switch any point up to the end of your, the beginning of your second year. So if you feel you've made the wrong choice, you can just switch, and that's kind of automatic. So in the final year, the thing that makes it really specialised is the third year project. So this is a project that runs through your final year, counts for a third of your marks, and it gives you a chance to explore a topic of your choice in depth. You get one-to-one supervision, and it's a really good chance to do something that's very relevant. It's a showcase of your talents for future employers. So one of my students has just, so I have an inspired navigation algorithm, and he's put it into an app for a mobile phone that I'm going to use in my research. I'm going to use it for demoing, and he's done that. So you do something that's very real, very relevant, that you can then take to an employer, and they say, well, what can you do these things? You say, yeah, I've done this. Okay. So this is an example of one of the projects. Well, these are so this is Jake, who did a project with the motion capture suits. This is a research project going on in Sussex, and he made a game. His challenge was to make games for this project, but games that you could play over the web with other people over the network. So it looks like a straight kind of graphics and web, graphics and sound sort of project, but actually the most difficult bit of this that project was to get the suit to talk quickly enough to the computer and over the web that it could play properly. So it turned into very much a more sort of core computer science project. But there's elements from everything you have to do a whole package. Here's some other ones. An interactive tax return application for students. This got the BCS Best Project Prize. So these are, I think, the prize-winning projects from the year before last. Something for retrieving and organising images, interaction with a robot percussionist, location awareness for Facebook, machine learning language identifier. These are the sorts of things you're going to be specialising in when you come out in your third year. Okay? This is where we're going to get you to doing this sort of thing. There is an industrial placement now. It's optional for both students and employers. You don't have to do it. They don't have to pick you. It is paid. It is before your final year. It's fully supported, and it will be assessed with a light touch way, but it means you'll get a degree with an industrial placement year. However, if you don't fancy doing this, there's also summer placements available. A lot of our students do work over summer in Brighton, doing coding for various companies, and a lot of people feel they've got enough experience that they don't need to do this bit. So it's entirely optional. You can do it if you wish. There are lots of companies, as you've seen, that are offering these placements, but yeah, we'll just shift from that. So our students do lots of different jobs, anything from programmer to a management consultant to video production manager. So Nick is managing his own company, which he set up after making iPhone things. Eric is working for Last.fm, kind of AI project tracking music listeners' habits. And Ian is working for the BBC doing video. Okay, so a bit of a whirlwind tour of the things we do. And now over to Paul, who's going to tell you a bit more about the
two of our other degrees.
Two of the other degrees. Thank you.
Okay, hello, welcome. I'm Paul Newbury. So over the next 15 minutes, really, I'm going to talk to you about some of our sort of more creative, I like to think, degrees, and that's the Computing for Digital Media and the Games and Multimedia Environments degree. So, like all our degrees, they're 3 years BSc honours degrees, and they're here. I know Andy has mentioned that we are informatics, but essentially we're a computing science department. So, in the same way as Andy split his degrees up and looked at them by using different icons, I'm going to use those to give you an idea of the components in these 2 degrees. So, just to explain what these components are, so we have video. Obviously, you're sitting in a video studio at the moment. Video is a core component of the Computing for Digital Media degree. Sound and music is going to come into both of these degrees. It's important to have audio resources. 3D graphics, likewise, is a large component of both of these degrees. And combining the computer graphics with the video gives us video effects. And that's a key part of the Computing for Digital Media degree. And then we have the basis, the theoretical basis for all of these things, which is the computer science. So we have programming. Everybody does programming. Everybody learns programming. Web development, that's going to be a key platform for your provision of the media that you're going to create if you're on these degrees. Artificial intelligence applies more to the game degree, really, than the digital media degree. And as Andy mentioned, professional issues runs through all of our degrees. So we're not only teaching you the subjects, but we're preparing you for the real world, going out and getting a job. Okay, they split up rather nicely into 2 areas, the digital media area and the computer science area. Okay, so let's actually have a look at the degrees. Let's start with the game degree, games and multimedia environments. See what I did there? Very clever. Yeah, took us ages. Okay, so that's the front of the brochure. Hopefully you've got one of those. If not, you can probably pick one up on the way out. And this gives you an idea of the subjects and their weighting. So programming, there's a significant amount of programming. I know a lot of you probably play games and they're fun to play, but to create games is really quite complex. They're quite complex software applications, particularly if you're talking about sort of big selling games, so you have to understand how to program. There's a bit of AI because our games generally will need some, or quite often need some kind of artificial intelligence, at least an approximation of that to make it an interesting and fun game, and 3D modeling. Not all the games you produce will be 3D based, okay, so we do some 2D gaming, Flash and JavaScript type gaming, but a lot of the big games are 3D games, so an understanding of 3D, modeling and interacting with 3D is very important. So to give you an idea of the sort of 3D modeling on the modeling side, before we talk about interaction that we do, we've got a clip from a bit of coursework that the students do. Okay, so obviously when you're doing the game degree, you take that on, and then the next part would be making this interactive and controllable by the computer in real time. In addition, you do a bit of video, okay, so you do a little bit of video because that's a key part of many games. Web development, you do quite a lot of web development actually, because that's going to be the end platform for a lot of the media you produce. An understanding of sound and music, very important. Games without sound don't tend to be that much fun. And professional issues, which is through all of them. Computing for Digital Media, this is really a technical digital media production degree, okay? So it's got a lot of video. So we're in Studio One here. You will use Studio One to produce pre-recorded video and to do live presentations, okay? So you'll be producing magazine-type shows and understanding how to technically produce a show and things like that. You'll do a lot of modeling, and you'll be combining the modeling and the video to produce visual effects. So we've got an example of some visual effects here. So we needed a shot for a movie where we had somebody coming out of a forest into a nuclear bunker. Now, we don't have a forest on campus, but we do have a nuclear bunker, and there you can see. So this is original footage that we shot of the actor walking into the nuclear bunker on campus. So what we had to do in post, we had to remove the background, we had to remove the other buildings, replace them with the forest, and then there's a series of different filters and applied methods that we have to use to get the shadowing and the colouring right, so we get the final shot correct, so it looks like he's actually walking out of the forest and into a nuclear bunker. And visual effects are extremely important. They're used all over the place. You might just think, oh yes, okay, yes, I'm sure they're used in Doctor Who. Okay, so Doctor Who uses visual effects all the time. But they're used in most films, films you wouldn't even imagine. So the King's Speech, I'm sure a lot of you have seen the King's Speech, uses a significant amount of visual effects there. So things like the stadium scene. There's thousands of people in a stadium. They were never there. Okay, it's all visual effects. It's all made up using modelling and video. And in fact, one of our ex-students from Computing for Digital Media worked on that film. You do programming. Everybody does programming. You can't produce interactive digital media without an understanding of programming. Web development, again, that's going to be the end development platform for a lot of the material you produce. More and more if it's going to be video nowadays. Sound and music and understanding of that's very important, and again, professional issues. So hopefully that gives you an idea of those 2 degrees. They're really quite different. One's a technical game development degree, and the other one's a technical media degree. Okay, and so they've got really quite different flavours. So, as Andy mentioned, part of your degree is your final year project, and that's going to depend on the degree you're doing. And for these projects, it's very much based around games and digital media. And so to give you an idea of that, we've got a bit of a video of a previous Computing for Digital Media visual effects final year project.
So the idea of my project was to land a helicopter somewhere on the University of Sussex campus. And to complete this shot, I'd have to use a combination of 3D modelling, tracking and 2D compositing. So to begin with, we went to the location and we recorded what would become the backplate of the scene. This then needed some image manipulation, such as colour correction. This sort of took out all the highlights and sort of made the scene look a bit grungy, like it was a sort of a stormy day. I modelled a helicopter using Maya, and then this was rendered out using multiple passes, such as a diffuse, specular and shadow passes. This all then also needs to be colour corrected within the scene. Another part of my project was to have a human, a real person, jump out of the helicopter. And obviously we couldn't do this any other way than using blue screen. So the actor was recorded jumping off a table in front of a blue screen, and this was later composited into the shot to make him look like he was appearing from the helicopter. There were loads of leaves on the floor on the day of filming, and these weren't wanted within the scene. So to get rid of these, a new floor was created and it was just laid over the top. This was then colour corrected to make it match the scene. But then leaves were needed for the shot, because obviously if there were leaves, they would be blowing around as the helicopter came down. So to do this, on the day of the shoot, a bloke was filmed running around with a leaf blower, just blowing leaves. These leaves were then cut out using alpha mapping and just sort of laid over the top of the scene to create a sort of another layer of realism. The final shot needed all the markers used for tracking removed. The 3D model of the helicopter also had to be tracked and animated within Maya. And then the final stage of the shot was to add sort of just a particle pass. I really enjoyed doing this part of my degree. It was definitely the part that sort of forced me to learn the most out of my entire sort of time at Sussex. And I enjoyed it so much that I'm actually going to the Vancouver Film School this coming year to study 3D animation and video effects, and hopefully pursuing a career in video effects and 3D in the future.
Go off to the Vancouver Film School. He graduated and he's now back in London working for a visual effects company. Okay, so hopefully that gives you a flavour of the 2 degrees that this sort of facility supports. If you want to know more, you can go to the Media Technology Lab website, which is mtllive.com, and you can find a bit more about the degrees and a bit more about the facilities. But what I'm going to do now is I'm going to show you a bit more of the facilities, and we're going to have a virtual tour. So to avoid having to get you all up, I'm going to take Thanos with camera 4 over there and show you the rest of the facilities. But we'll start off in here because this is Studio 1. This is our main studio. As you can see, it's pretty much a standard television studio. We've got lots of lighting in the ceiling. A lot of our lighting now is LED based, which means we can change the color of those lights in real time from the gallery, so no longer do we have to get up and put colored filters in front of lights, and it means it's a bit cooler in here. We use quite a few microphones in this presentation, although I'm just using a tie mic today. We've got numerous cameras, including a boom camera there, which can give us some very interesting shots, and we're using about 12 cameras in today's presentation in total. So this is a very flexible space. So for instance, if you had a band, you could bring them in here, we could put them in Studio One, we could mic them up and video them at the same time. We could then take the sound signals into our sound room, we could mix them together, we can edit them, we could burn them to CD, or we could put them out as an MP3. So a very flexible space. In addition to that, all students in the first year get to use the studio. They'll do a presentation in front of the camera, it'll be recorded, and then you'll be able to view that back on the internet. So it's a really good mechanism for getting feedback on your presentation skills. Okay, so this is Studio One. So if you just stay here, I'm going to take Thanos and show you the rest of the facilities. So if you stay here and watch the screen, I'll go to the gallery. So this is Gallery 1, I'm going into here, and as you can see there's a bank of monitors here. We're showing all the signals we've got coming from the different cameras and the different VTs we're using today's presentation. We've got Phil, Gus and Ben here who are controlling things today, and they're controlling everything you see on the screen in front of you, but also they're controlling everything we're sending out. And in fact we are webcasting this, so here's a nice webcast on the iPhone. You can notice that this is really quite lagged behind what we have. I don't know if you can see that properly. Okay, so it's a bit laggy, okay, about 20 seconds or so behind. And that's because it takes us about 20 seconds to compress it down and stick it out on the internet. So they've got, as I said, got full control, and that means not just full control of the stuff coming from the cameras, but also VT, and we've got a video that we can queue up and play now. Okay, so that's the gallery, that's the control room, but we've actually got a second gallery in studio, so let's go and have a look at those. So we come out into the corridor. So having two galleries and studios means we can run big presentations like we're running today, and it also means students can work on things in parallel when they're doing other projects. So we come into here, this is Gallery 2. Okay, this is being controlled by Shan today, and as you can see, similar to Gallery 1, it's got a bank of monitors, and this is showing all the signals coming from the cameras in Studio 2, which Shan is then controlling, sending back to Gallery 1, and Gallery 1 is then putting onto the screen in front of you. So we've actually got Studio 2 set up for a little demonstration, so if I leave Shan in charge here and go into Studio 2, so if I come in Studio 2, and you'll see it's dominated by a green screen. Okay, so there's a big green screen behind me. And that means that because I'm not wearing any green, we can remove the green in real time and replace it with, hey presto, the weather. It had to be the weather really, and because it's the weather, I actually have this clicky button, and I can say that's what the satellite picture looks like today. It's looking a bit wet up north, and it's looking very sunny down south. In fact, the sun always shines in Brighton, it's just that sometimes the clouds get in the way. Okay, so hopefully that gives you a good idea of the type of facilities we've got here, particularly what the studio has and what is involved in that. What we're going to do now is play you out with show reels from a film we made recently. And if you look in this show reel, you see a lot of blue background going on. And that's where we're using blue screening rather than green screening for the chroma keying. So we're going to play you out with that.
Oh no, Nicholas, don't be so ridiculous. You've heard that, obviously haven't you? You've heard that one?